Bizarre CPU design choice alert. I just discovered an obscure microarchitecture trick used in some high-end server processors to boost IPC. The data forwarding mechanism relied on a clever exploitation of the in-order and out-of-order execution pipelines to minimize hazards and increase resource utilization. Here's how it works. The processor issues an address to the L cache, but before the data is actually read, it sends a speculative request to the L2 cache, essentially betting it will be present. If the data is found in the L2 cache, the processor can immediately forward it to the next stage, bypassing the L cache, drastically reducing access times and TLB misses. On the other hand, if the data isn't in the L2 cache, the processor will stall and wait for the L cache access to complete, minimizing unnecessary traffic and power consumption. This early prefetching technique was first introduced in some Intel Xeon series as a low-power idle mode and has since been popularized in even more cutting-edge server CPUs. In this breakdown, we'll also explore some interesting edge cases and applications of this still relatively novel microarchitecture innovation. From automating hyperspeed trades on high-stakes financial markets to unleashing radical performance gains in CPU-intensive machine learning research. Experimenting with data forwarding by hand is virtually impossible, even with an open-source emulator, due to the intricate co-design of the microarchitectures and accompanying toolchains. The entire microcode stack, instruction decoding, and specialized microtasks running on the hardware queue must all be perfectly synchronized for this tiny window of optimization to occur.